Suppose I want to find the two cards are drawn at random without replacement from a pack of cards, and let X denote the number of hearts obtained. Okay, I need to find the probability distribution of X. Okay, so first of all, we take it that we are drawing first card followed by a second card. So if we can also use a tree diagram to represent this, right? So there are a total, we are drawing two cards, right? So there can be a total of, we let X denote the number of hearts as obtained. X will denote the number of hearts obtained, right? The hearts obtained. So the thing is, now for us to really look at what's the probability of getting the probability distribution of X, we know that if we are drawing two cards, right, we can be getting 0 hearts. Okay, because we are drawing two cards, we can have like probability X can be 0. Right, so it means that we are drawing 0 hearts. We can also have the probability that X can be 1, correct? We can also have the probability that X equals to 2. Right, so what does this mean? What's the probability that X equals to 0? It means that we draw 0 hearts. And we can see as the number of ways not to draw any cards. So there are total of, if you think about it, there are total of 13 hearts in the card of one deck. And there's a total of 39 non-hearts. Okay, so if looking at this, we want to draw 0 hearts. This is like, I totally don't choose any. I mean, it's like I say 13 hearts, I choose 0. Okay, which is very trivial. And then out of the 39 non-hearts, I'll choose 2. Alright, over the total number of ways to choose 2 cards. So total number of ways to choose card will just be 52 over 2. Right, so remember that the probability of A can be the number of ways that A happens over the number of elements in the sample space, right? So this is what we are doing. We're actually looking at that. Okay, then probably X equals to 0, or probably X equals to 1 would just be 13 choose 1. I'm choosing 1 heart from the 13 hearts, and I'm choosing another 1 heart from the 39 non-hearts over 52 choose 2. Alright, and by the way, this answer here would be 19 over 34. You can simplify it now, okay? And over here, the answer you will get is probably 507 over 1326. And using your calculator, you will obtain this answer to be 13 over 34. Alright? And probability of X equals to 2 would just be equals to 13 choose 2. Means out of 13 hearts, I choose 2. Out of the 39 non-hearts, I choose 0. Okay? And out over 52 choose 2. Of course, if you choose not to write this, that's fine also, because this is actually 3, it's just 1. Right? This will be 78 over 1326. And we equals to 1 over 17. Some of you actually will use another method. So instead of using the PNC method, probability of X equals to 0, you just put like 39, probability of 39 choosing 1 card over 38 over 51. That will be fine. Right, so I'll just write down the other way of finding it. Right, and this one can be times 2. Right, because you can be choosing 1 non-heart. So non-heart followed by 1 heart. Also 1 heart followed by non-heart. Okay, so here if we are doing this method, we have to take into account that, if I look at it as a tree diagram, it can be me choosing a heart followed by a non-heart, and then followed by a heart, non-heart followed by a heart. So there are actually 2 ways. So when we're doing it in tree diagram format, we need to consider that there are 2 possibilities. And lastly, for the last one, it will just be 13 over 52 multiplied by 12 over 51. Alright, and all I need to do is to compile it in the table format. So given that we are gonna compile and show the probability distribution of X, remember this is always how we go about doing it. We show a table, first one will be X, and followed by its own matching probabilities, where X can be 0, X can be 1, X can be 2, and for X equals 0 will just be 19 over 34 as we found earlier. Right, 19 over 34, 13 over 34, 1 over 70. I'm just going to put it all down. Alright, and that would be the probability distribution of X. Alright, so one key thing you can see is that first, all of these should sum up to 1. So the probability of X equals X always adds up to 1. Okay.